Good evening, everyone, and welcome to the October meeting of AREG. So my name's Jared, VK5SFA. I'm the president, and I'd like to welcome everybody here this evening. A lot of familiar faces, a few visitors, so it's great to see. So without further ado, I'd like to introduce you to Steve, VK5SFA. Evening, Steve.
Hello there.
And tonight he's going to give us a very in-depth presentation on the investigations and experimentation and getting up and running with ATV. So thank you, Steve.
Okay, thank you. All righty. Well, good evening, ladies and gentlemen. Thanks for coming along. Thanks for coming into Zoom to look at this presentation. I'm a bit warmed up. I managed to give this presentation last week at the Northeast Amateur Radio Club. Very welcoming. So I've made a couple of little enhancements, a little bit more polished, I hope. Look, for those who know me, I like to deal with questions on the spot. I don't like to wait till the end. So please, if you have a question, just interrupt. Wait till the microphone comes to you. Please say who you are and your call sign. And then please feel free to ask the question. The same applies to Zoom. Grant is watching there very carefully. I think it's the best way, because then we can just be done and dusted with the presentation at the end, because I'm sure you'll all want a cup of tea. All right, well, look, I've normally done death by PowerPoint, but it's going to be fairly short sort of a PowerPoint tonight, just to give you a little bit of background on how it all sort of goes together. From there, we'll go into a little bit of a practical demonstration. So if you might look to my right there, you'll see the equipment that I've got set up. So we'll just go through that piece by piece. And after that, then I'm going to show you how to tie it all together, because you can most certainly have the, you can put the camera back on me now if you want. It's on, yep. How you put it all together, because you can technically have the best setup in the world, but if you haven't got the content to put on it, like with anything, no one's going to be interested in watching what you have to do. And there's just some remarkable free pieces of software that allow you to do it just so easily. So I'm going to go through the whole lot there. Okay, so if you don't mind, I'll sit down, because I can then drive my PowerPoint presentation properly. It's not my job to explain how DVB-T works. It's a really mature technology. We've had it in Australia since the early 2000s. It's how you watch television today. It's very well documented, very well understood. The only enhancement is we went from the old MPEG-2 standard to MPEG-4, and hence these days it's referred to as DVB-T2. So for those of you that got the email, I guess the things that you need to look up, obviously DVB-T, I've just described that. COFDM, or coded orthogonal frequency division multiplexing, which is really just a fancy term for a bloody lot of carriers in a piece of spectrum that all carry low data rates, that when you combine them together, you can get up to 23 or 24 megabits per second over a 7 megahertz RF channel. QPSK, again, it's a very robust form of keying in a digital format. Gives you very good carrier to noise, signal to noise if you wish. And in amateur radio, it's chosen because you can get further range out of it. Certainly QAM, or quadrature amplitude modulation, is required when you need more symbols in the constellation, but it becomes more fragile and your carrier to noise needs to be better. So, and we'll talk about why we need that. The MER modulation error ratio is a bit like signal to noise ratio, if you like, on the transmitter side. It's just, in simple terms, the health of your system. The higher that is, the better, and the further distances you'll get. The whole scheme uses forward error correction. Reed Somerlin and Viterbi are the two standards that are used. They wrap that all around the data, and again, you can send bits along with your transmission that will allow for error correction at the other end if you have corruption along the way. Our guard interval, again, not going to go into huge depth. We've just chosen a length here in Adelaide. There's quite a lot of flight movements. It really affects the Doppler performance of the COFDM signal. You can choose 2K or 8K carriers. We've chosen 8K. The packet identifier is pretty important in that it sets out the logical audio and video idents, if you like. and it allows your set-top box to resolve them and memorize them, and then you can have logical channel numbers. But I just encourage you, if you haven't written all that down, take your phone, take a photo of it, and go and research it if that's what you want to do. If you simply just want to be a viewer and that's all, don't worry about it. We'll talk about that. Just buy a set-top box, plug it into an antenna of some description and plug it into a monitor, and that's all you've got to worry about. We'll move on. So basically, the hardware and software that you need, well, there's really sort of 4 or 3 parts to it. You have things called encoders, which, as the name implies, you can encode your video and audio signals onto a stream that you can plug into a modulator. And the modulators can be ones that are just used for cable or MATV around a building. That's exactly what I'm using. You can buy boards. I know the British Amateur Television Club have them. Lime SDR is another example. There's lots of ways that you can generate a DVB-T 2 signal. When it comes to receivers, set-top boxes, which I've talked about, I've got an example here and an example of a small power amplifier I'm going to pass around locally. You can have a look. Some televisions will actually tune into 445.5 megahertz, which is the 70 centimeter allocated amateur TV channel here in Australia, and some USB dongles will do it too. And I'm sure there's more, but you get the idea. You just have to have a little bit of a look around. So basically, the workflow, you have a HDMI input, which you need to feed with some content. We'll talk about that later. An encoder into a modulator, into a power amplifier, most importantly into a filter, into a transmit antenna. It goes across the ether, finds its way to a receiving antenna, into a receiver, and into some sort of monitor. But sometimes a graphical representation is much better to understand that. So hopefully my little laser pointer is pointing here. So there's your HDMI input. It goes into this modulator in my case, which I have here. Modulators, as we'll talk about, they're actually really quite cheap for MATV use. It's when you start to get into multi-channeling and you have to buy a very sophisticated encoder. Those encoders are horrendously expensive, and the transmitters these days tend to be more internet protocol inputs on them. They used to be STI, but now more IP, and that's fine. But that's where it really starts to get expensive, and I think out of the realms of amateur activity, unless we wanted to do a repeater perhaps, but we'll talk about that in a little minute. Output of your linear amplifier chain has to go into a bandpass filter if it's over about 1 watt or so. As I say, into some sort of transmit antenna, received by a receiving antenna into some sort of DVB-T receiver, whatever that may be, and onto some sort of display. It's pretty much as simple as that. It's not that complicated. So the core concepts, the encoding these days is MPEG-4 on H.264. I'm sure you're all familiar with that, with things that you maybe look on the internet and what have you. Each carrier carries about 188 bytes of packets. And then you have 8,000 of them, should you wish to go that way. As I said, the modulation is DVB-T, coded orthogonal frequency division multiplexing, and the bandwidth, as I touched on, is 7 megahertz. That's what we're set up for here. It is the exact Australian standard, except for the fact that we in Adelaide here and others tend to use QPSK, but we'll go to that in a moment. So why go digital? Well, it's efficiency. You can have more channels for the given spectrum if that's what you want. It's certainly robust. As I say, using QPSK and forward error correction really improves the reception distances, and you'd be amazed how little power you need to get all across Adelaide. It really is quite astounding. Look, you can do multiple channels and different audio, different data. With more expensive equipment, you can integrate it using IP workflows and streaming, which we'll touch on. The software that I'll talk about later allows you to do such a thing. You can accept a video and audio stream from somebody else and then put that through to the transmitter and rebroadcast it out. It's just amazing. High definition, excellent picture and sound quality. It either works or it doesn't. There's really not a lot to think about there. And it has this thing called the fall off the cliff effect. It either works or it doesn't. And that can be within 1 decibel at your receiver antenna terminals. I've tested this, and literally by putting 1 dB more attenuation, you lose the picture and the sound. You bring it back 1 dB and it's there like it was as strong as it could be. So very, very good. All righty, well, this is a little, just a slide here of a low power setup. It's actually here in the hall today, and we'll have a little bit more of a look practical, but just to describe the different components. So I chose on a brand, it's called a SatLink. There's many different types of DVB-T modulators. This is a single channel one, so you can't do multi-channeling on it. You just put 1 HDMI input, or in this case, you can put analog input into it. Choose either one, and it will faithfully encode that to DVB-T on whatever mod code or modulation coding scheme that you choose. It outputs about -6 dBm at the F connector here. And from there, I need a bit more drive. So I've used one of these little things that they're affectionately termed called the golden amp. And you can get these anywhere. You can get them off Amazon or eBay or AliExpress. By the way, this SatLink came from AliExpress out of China. It was just 1 week. And it was about $155 at the time. Just cheap as chips, really. The little amp, I think, was about $17. But that's when you've got to start to be very, very careful, because from there, it's unfiltered, it's full of harmonics. You've got to be very careful about your spectral purity. But in this case, I coupled it up with a MiniKit's 450 megahertz low pass filter, about $50. All you need is a 4mm drill bit and a soldering iron and some very steady hands, and you can build it up, and it works superbly. I'll show you some spectrum plots in a moment so you can see. From there, I decided I would also go with a MiniKit's 60-watt Mitsubishi PA module. Now, these are predominantly designed for FM use. And the one thing with DVB-T, which you do need to understand, is that the amplifier has to be ultra linear. If you have non-linearity, you'll bugger up your MER and you'll get very poor distances, or it won't work at all. So out of that module there, and it's pretty heavily heat sinked, if I take it to any more than about 3 watts, it'll just start to trash itself. So I find about 1-2 watts out of that, and it works very, very happily. And that's what's running here at the moment. We've got a DVB-T signal launched in the hall for those that have bought a set-top box in for later on, that we can help you tune it up. You can see here that I've incorporated the low-pass filter in the box. Now, Mark says that you actually should put it in a separate box, but I found it didn't make all that much difference. So what am I talking about? Well, that is a spectrum from 0 to 1.5 gigahertz, unfiltered. So you can see a lovely big second and third harmonic there, and that's just running at normal power, right? It's linear, but doesn't mean that not harmonics there. You put it through Mark's little filter with less than half a dB insertion loss, and you get that. And that's what you want. So the spectrum's nice and clean. And in some respects, we can have a talk about it a little later on. You can get away with lower power and maybe just that filter and not potentially interfere with other services, but we'll explore that in a tick. So I built that myself. I like building little bits and pieces. I certainly didn't design it. It's Mark's design and others, and it works particularly well. Very stable, easy to do. You just got to make sure everything is heat sinked nicely, because of course, you know, for my 3 watts, I have to use about 30 to get that power out of it. So now, if you don't want to go down that road and you just want to use your wallet and have instant gratification and fun, and there's nothing wrong with that approach, by the way, you can buy yourself one of these little things. So this is a little 4-watt, and I'm going to be very, very, very careful here and tell you that it's 4 watts PEP. It came from China. Look, it's got 4 watts written on it. Must be 4 watts. Fantastic. Great. Yeah. Well, I put 4 watts into it and blew it up really quickly, let me tell you. They're good for 1 watt RMS, 6 dB down. So just be very careful. Under $100, again, from AliExpress. Can I just get someone to come up? I want to pass that around. You can have a little look at it here in the hall. I'll show you another photo of it for those out in Zoom land. Really well made, just not labelled properly. But anyway, you find out the hard way. The new device was only about $8 or $9, so it really didn't matter. It was just a bit of time to fix it. And there's a view from the top, as you can see. So nice little thing that'll give you 1 watt. So your modulator into your little golden amp, into that little thing, into a filter, the low pass filter. And I honestly believe you can get away with that into a Yagi-Uda style antenna. And the potential for interference to other services is pretty low, I would suggest. So what a perfect segue to get to the serious part of this conversation. Please do not misconstrue what I'm about to say as a naysayer, doomsayer, that it's bad. I think you'll see where I'm coming from when I've finished having to say what I have to say about this. So we really need to be careful about spectral purity, and I want to explain why. So our DATV channel goes, just get my little laser off here, goes from 442 to 449. The center channel's 445.5. That's what we're allocated. That's what we really do need to use. No real reason why you couldn't go down in bandwidth and so on, but everybody's got these set-top boxes, and you've got to understand that these set-top boxes, once they see a valid channel and a valid PIDs, and you memorize it, if the channel's active, so there's RF there, if it's got a different bandwidth or the PIDs are different, you'll get a black screen. You'll get no sound. You won't know what's going on. So if I digress slightly, the 3 transmitters here in Adelaide got together and we all agreed to use the same PIDs on our transmissions. So 1 memorized channel on your set-top box in Adelaide, as long as your antenna is pointing at either Steph or 5FQ or Tom, 5ZTS or myself at the moment, it'll just work. Good idea. So 442 to 449, that leaves us a 1 megahertz guard interval, and the commercial services technically start at 450.000, but the first channel is 25 kilohertz up from there. So if there's only a 1 megahertz guard band, you know, I would argue with the Spectrum Planning Committee, it's too late, the horse is bolted. Maybe we should have gone down and had 2 megahertz at the top. But that's just my own personal view. As I touched on, I think up to 1 watt PY into a high gain Yagi-Uda antenna is acceptable without a bandpass filter, but you have to put the 450 megahertz low pass filter, and it's a must. You've got to get rid of those harmonics. It's just got to happen. So as I say, any channel power over a watt must incorporate a bandpass filter, and we'll have a good look at that and talk about that in a moment. We must only use horizontal antenna polarization because the majority of these services in 450 to 455 megahertz are vertical. So you're getting 20 dB gratis, which is pretty important. But that then creates its own complexities. So how do you make a horizontally polarized omnidirectional antenna if that's what you want to do? At any rate, the really sobering thing is, and it's the last bullet point here, the closest users on 450 to 025, it just happens to be SA Water and Adelaide Airport. Yeah, they're 2 services you don't want to interfere with. Because if you interfere with them, I'll guarantee you that the radio inspector will be knocking on your door within not long and will confiscate your equipment. And if it happens too often, I believe the ACMA will say, this is too hard, amateurs are now forbidden to transmit DVB-T. Okay, so that's the gravity of what I'm trying to say. There are technical solutions around this. As long as we're all just responsible and understand what we're doing, and that's the message that I'm just trying to put across. That's a little plot. Thank you to Grant for supplying that to me. That is every user in Adelaide within 100 Ks between 450 and 455. They're everywhere. So don't think that you can just fire up, because you can't. So how do you get around these problems? As I said, I'm not here to be a namesayer or doom and gloom. You can start to use filters. Filters clean it up really nicely, and I'll demonstrate that. So here is a photograph of a commercial comb line filter. You can get interdigital types. The interdigitals just have the digits opposite one another. This one is all in one line, and all the earthy ends are down one end, and these capacitors that tune them are all at the other end, and these little rods here are the coupling rods, and then they have these exquisite little injectors. Now, this one came out of commercial service. It was on channel 28, where SBS sort of used to be. It was at a country repeater somewhere or other. And I was given it, and I tried to walk it down to 445.5, But at about 470 megs, it collapsed. It just wouldn't hold the filter shape anymore, which was a bit of a pity. So I did some experiments and I just tried adding some length to the digits to see if we could get it back to a nice shape. And I was very, very fortunate just by adding some little aluminium tubes, which from AliExpress, from a bespoke dealer there, that gave me the exact inside dimensions, interference fit with a tiny little bit of shim. I lengthened them, as you can see. So if I go back one, you can see that's at I think these go from 528 to 600. That's where they go to. Make them a little bit longer, and they tune perfectly on 445.5. And I was so ecstatic with the result. For those of you who can read S1, S2, S1, S21 plots, we can see here the three markers there on the channel width, and the best is at one edge is about a dB, 1.2 in the middle, and then it was a little bit higher, nearly 2 dB at the other side, but didn't seem to really matter. And that was an excellent result. So you're not wasting all your hard-earned power heating up your filter. Some other experiments that I tried in the early days was the use of some notches. So another solution, if we can't get bandpass filters, is potentially use a mini-kit's low-pass filter and some notch cavity filters, but use them in a notch mode. So for those of you who don't know, if you just open circuit one side of a bandpass filter and put a T-piece on it, it turns it into a notch, just like that. So you can see my little test setup here, just a pair of notches. So here's a look at the actual response of those two filters. So you can see here, there's a notch here at 441 and another one at 450, and pretty good insertion loss across the top. And that worked really quite well. And if we look at it, how it affects a transmitter transmitting at the spectrum. So that one is just the transmitter unfiltered. And you can see, around here at 450 megs and 441 megs, there's a bit of energy there that we've got to think about. Let's just say we did have a problem with Adelaide Airport or SA Water and whatnot. Just stick in a notch and look what you can do. You can get a really good depth there. And it may necessarily be that this other here is not interfering with anybody else, but Adelaide Airport was there. No problem, it's gone. So these are some remedies that are available without having to try these other filters, which are very, very difficult to get. All right, we'll move it along. Here's a picture. This is the setup I have at home now. So it's never what you know, it's who you know. I used to work in the broadcasting space as well. That's a 50-watt commercial transmitter. It's a very old one, but see, it's a DVB-T one nonetheless. Not very power friendly, let me tell you, but nonetheless, I'll just walk you through the system so you can see the little modulator at the back here. I used my mini kits as a sort of an IPA, if you like, and then just fed that into the power amplifiers of this great big one, and it gives you 50 watts out. Having said that, for a commercial transmitter, I think moving it below 470, and by the way, this came from Europe, and their TV band goes down to 470, so hence why they actually tune at 445 without too much fuss. There was nothing to do, but you do have to put them through a filter, and that's I was given a commercial, it's a higher power DVB-T filter. And this one has 4 bandpass digits and 2 notch digits. So it incorporates what I showed you before, the one of the bandpass and then the notch cavities. It incorporates that into the one box, and you can get a terrific response out of that. And where I tune it up for the best MER, about 21 watts to the antenna, which is a fair amount of power, especially where I live up pretty high, and the antenna system I'll show you in a moment. So again, that's at full tilt. That's at about I think it was about 40 watts, that one. And that's without a filter. That's just raw through a power attenuator into the spectrum analyzer. Add the filter, and that's the effect of the filter. So it cleans it before, after. So you can see how important it is. So, Adelaide Airport's down in here, whereas Adelaide Airport is here. So I think you're all understanding the issue. But again, remedies. I have a little test set that I bought. It's also made by Satlink. This thing is designed for DVB-T or DVB-S, so you can use this to look at your terrestrial television, plug it into your antenna socket, have a look how well your antenna's lined up, your masthead preamps, and it gives you all the things that you need to know, the PIDs that are required. These are in hex, by the way. In the modulator, they're actually in binary, in decimal, so same number, just a different format. Gives you the MER, all that sort of stuff. And that was about $160. But I felt you just needed the test gear. If you're going to launch these things to air, you've really got to know kind of what you're doing. Finally, at home, so that's my little mini rack now. Got all my HF stuff up here, and then the TV business down the bottom. So it's available at any time. And I've got a few viewers, a couple of very good friends, and we'll be talking about something or other. And I'll say, "Oh, look, I'll show you a picture. I'll show you a quick video," and just pop it up there, and they go, "Oh, yep, I can see that." As far as coverage, one of them's Neil 5KA, who you've probably heard of. And Don, who's here tonight, but both Don lives in a singly obstructed path by mountainous terrain. Neil has a double obstruction between me and him, so absolutely non-line of sight. Works perfectly, just knife edge over the hill. And because we're using QPSK and enormous forward error correction, and the receivers are pretty darn sensitive, and he's got a little Yagi, he can see me anytime, day or night. So that's my setup. Just quickly, how did I transmit it from my house? So this is something I tried some 20 years ago on 23 centimeters. I thought I would just scale it down to 70 centimeters. So my transmit antenna system consists of three 4-element DL6WU Yagis. I built them myself. Most importantly, they're all timed, so the transmission lines are all the same length, so that they launch the signal at exactly the same time. I built a little 3-way power divider, again, out of all materials I could get here in Adelaide. That's just a coaxial one. It has a piece of copper pipe running up the middle. It transforms 50 ohms down here via a quarter wave section of 30 odd ohms, and drops it down to 17.5 ohms. So all you do is put 3 50 ohm antennas on there, and it divides your power 3 ways, just Ohm's law. It's really, really cool. That was just when I was sort of setting it up in my spare room, getting it all correct and ready. But I really was rewarded for my efforts with a beautiful return loss and a fantastic passband. So it worked particularly well. And there it is in the final situation on top of the roof of my house. So this Yagi here points due north. This one here points due west. This one points due south. And they've got a 60-degree beam width, so they just all overlap. So you'll have a sort of a 3/4 cloverleaf thingy. And I'm sure there are phasing locusts in it, and I don't know because it just works. So who cares? So that's pretty much what I do at home. What I'd like to touch about for everybody here and out in Zoom is receiving now. Just quickly touch on that. So as I mentioned, you may have a DVB-T2 receiver at home that actually will tune 445.5 and you don't know it. So I'm going to give you an example of mine. So I have an LG smart TV. It has WebOS. So it's a slightly more modern one, be a couple of years old now. That's what it looks like. You plug an Ethernet into the back of it, and away you go. So basically, to tune it to the 445.5, you just go into the general setting, and every TV is different. Your mileage is going to vary. In my case, you go to a tab called Programs. You then go into Program Tuning. It all kind of makes sense at this point. It has a bit of a think about it. And then it says manual tuning. You say, yes, I want manual tuning. And then it says, do you want the digital TV or do you want analog TV? You say digital TV, please. It says, well, I can tune a frequency between 47 megahertz and 820 megahertz. Input your frequency. Okay. 445500. They're the numbers. Just remember that. It's always in kilohertz for some reason. Don't ask me why. You enter that in. You hit the magic go button. It goes update. And ta-da. You have an amateur TV receiver sitting in your living room. Now, I can see from my place with my domestic UHF bow tie that's pointed at the City TV translator, I can see Steph at Seaton through that system. So there's nothing special. I didn't even put a 70 centimetre antenna up. Now, she has got an excellent system. She has a bit of a cardioid keyhole array where she's got 3 panels, one looking west, one looking south, one looking east, and then a Yagi looking up to the north because she wants to communicate with Dallas and those guys up towards Elizabeth. Works really well. So that's one way of doing it. The other way is, and I might just stop here and ask my assistant to pass this little set-top box around. I'll show you some pictures of it out in Zoom land. That's a little laser STB 9000 that I've been banging on about. $40 at the usual retailers. That's the little box. Go ahead.
Sorry, do you have a question?
And name and call sign, please.
Graham, VK5 Romeo Echo. What does the M stand for in MER?
Modulation. Error ratio. No worries. So that's a little box that comes in. Inside the box, what do you get? Well, you get a power supply, a couple of batteries, a remote control, and the box, and a little manual. Don't really need it. So plug it in. You need a HDMI cable. They don't supply that. So you plug that into your computer monitor, switch it on. You'll be presented with this little welcome menu. So you pick Australia. Next thing, you go down to the DVB-T installation. Then you say DVB-T channel scan. Now you have to have a valid signal on the air. So if you haven't brought your set-top box in tonight and you go and buy one in the future, you'll need to make contact with either myself or Steph would be my recommendation. Get us to come up on the air for you because it won't tune without a valid signal present at your antenna terminal. Now, here's the most important bit. You've got the scan mode. You can do it by channel or by frequency here. So you just select by frequency. You type in the magic numbers, 445500. You hit search and just like that. Easy. All right. So that's how easy it can be to receive. All righty, well, as I said, that's enough death by PowerPoint. I'm going to now just switch over to a slightly more practical demonstration. Then I want to show you the open broadcasting system as software, as a service, and then we'll take some questions. Don, microphone.
Steve, for others' benefit, they might have seen that you had received 147.4. You might just explain that liaison.
Thank you very much. I would have talked about that, but why not while we're here? So that's my test pattern. You can see that I say, as Don rightly pointed out, 147.4. That is the Australia-wide allocated digital TV channel or amateur TV channel around Australia. And if I am on, or Steph is on, or Tom is on, or anybody who would love to become a transmitter, you've really got to listen there. And really good etiquette is, what I do before I come up is I'll say, this is VK5SFA, is anybody using 445.5? And if someone was using it and I wasn't beaming at them perhaps because it may look like there's no one there, but there might be someone there. So it's just always polite to ask, that's all. So that's what that's for. So all the talkback happens on that channel. Cool. Cool. All right, well, let me just fire up my OBS and we'll just take you through a little practical demonstration here. Pray to the gods that it all actually works. Excellent. All righty, so I have a little camera, for those in the hall can see it. I'll just sort of walk you through the setup the best I can. Forgive me, this is now a little fly by the seat of your pants, so I can just see what I'm doing. So forgive me with my back to you. So, because I wasn't. There we go, that's what I wanted. All right, so I'll get my pointer. Compliments of my wife, by the way. It's a very good little knitting needle. So this is the modulator. It's got a little display. I'm sorry, it's very difficult to see. I'll just try and point it out. But you've got some settings here. I'll just have to read them to you. You've got a thing called Quick Install. I can try just to put the camera down a little bit. We'll just see how we go. If it doesn't work, I'll just try to. I don't know how well we're going to be able to see this, but we'll give it a go. Okay, that's kind of reasonable. So yeah, so you know, you can set your country here, the channel name, in this case it's 00, you put the transmit frequency you want in, and this will go anywhere from 47 to 820 megahertz, anywhere you like, so be careful. We said 7 megahertz, it's got a attenuator in it. I need -14 for this particular setup. The signal source is HDMI, and the logical channel number is 100, and that's what show up on your set-top box. Okay, so when you tune it in, it'll say channel 100. And I did that on purpose because when if you do a full scan, you'll get ABC, SBS 7, 9, 10, and that'll end up at 10, and then 100 down the bottom. So you'll always have the amateur channel at the very bottom there. Next, you've got the DVB settings. So we said 8K carriers. In my case, it's QPSK, 3/4 forward error correction, and a guard interval of 1/16. Again, you can set that up however you want. It's entirely user selectable. Transport stream settings, this is the critical one. So we all agreed that the video and the audio, the PIDs will all be the same. So we've agreed that they will all be the same. As I said, they're in decimal. When you see them on the little Satlink box, they're in binaries. Sorry, in hexadecimal, but same number. System settings, so obviously in English channel, the modulator mode DVB-T. This also does the Japanese standard as well, ISDBN, I think it's called. Why would we do that? We don't. And you can have little key clicks and so on and so forth. It does have one other feature which I'm happy to talk about when the presentation's finished. So that's one of the reasons I bought it. Okay, so that's the little modulator thingy. So as I say, it outputs about -6 from the RF out. It does have an antenna in because this is designed for MATV. So you can feed your normal terrestrial antenna in here and it will combine the two together and send them on your coax around your building. That's what it was designed for. I found I got a much better modulation error ratio number by terminating that input, and I just used a pad because they use a transformer and it's a really wideband one and it just likes 50 ohms on one side. So that was the reason. It's got, as you can see here, HDMI input and the power. And that's pretty much it. Comes out of there into this little, just get the camera oriented correctly, this little golden amplifier that we called it. So it comes into the golden amp, out of the golden amp, then into the Mini Kits homebrew one that I made-ish. So comes as an input, obviously amplified, low pass filter, comes as an output. Then we come along here to, it's flaring a bit, sorry, but that's the filter. So this is a 5-pole band pass. That's the one that I modified. So it comes in here, comes out into a, just get that right there. Whoops a day. So that's just a 50 watt through line attenuator, extra 10 dB, and then just a two-way power divider. So then that outputs one to my power meter, which we'll touch on in a minute, and the spectrum analyzer, which we'll have a look at in a minute. Measuring DVB-T or anything with just lots and lots and lots of carriers is a very difficult thing to do. My tip is do not believe your spectrum analyzer. It can't do it. It cannot measure power. Just far too much bandwidth. It depends on what video bandwidth you're using. You've got to look at it as total channel power because there's 8,000 carriers in that 7 megahertz channel, should I say? And A bolometer like this simply takes that whole channel power, turns it into heat. There's a thermocouple in the head. It's calibrated. I have taken into account that I have 34 dB in line, and it will either read it off in dBm or it will read it off in watts, so 2.4 watts coming out of it. So most important to know what you're doing, and you do that in conjunction with looking at your MER, which we'll touch on in a tick. Last but not least, it's just a picture of the spectrum there going through the filter per se in real time. So that's what it looks like. If we fired up a receiver in this hall, it would if we did a channel scan, it would receive it. And then last but not least, we'll come back to the little test set, because I can actually show you there what you can look at with the test set, but I can't point at it because that's actually being delivered out of the test set. But you can see the power that's coming into it in dBm, you can see the MER, you can see the bit error rate. They're all quite inextricably linked. You know, if everything's good, it'll just work. And then you can see the transport stream IDs, the video IDs, the audio PIDs, everything like that. So really handy little bit of gear for $165.
Question, Mr. Steve. You've got your input power at neg 29. I know some work I did with free TV, that point usually would crush most receivers.
Yeah, so this is a test receiver, so you can...
Got the higher front.
Oh yeah, man, you can... I put 0 dBm into it without any problem. No, it's got a really wide dynamic range.
Yeah, a lot of the TV sets we tested in the labs in Sydney, we couldn't get them above about -50 before they clip.
I agree. This is a little test set. So that's that bit. So with that, what I'm now going to demonstrate, so that's the setup. Hopefully everybody got a good understanding of that here in the hall and on Zoom, I hope. So now what I'd like to do is just show you how on earth you can get program into this thing. So what I'm going to do now, I'm just going to not split my screen. I'm just going to make it one screen over both displays. So just give me a moment. Okay, so now I'm going to launch this OBS. So this is what you're about to see. So you're not seeing the output of OBS anymore. What you are seeing in actual fact is what I'm seeing as the provider of the video that we're sending out to air. Okay, so I'm not an expert at this. I'll try and walk you through it the best I can. The first thing I'll say is it's absolutely free. You just go and download it. It's open source, and the people who've written it and curate it do a fantastic job with it. There's lots of updates all the time. So we'll just start off over here. You can have a scene. So I've only got one scene. I just call it DATV. So that's everything to do with DATV. If you had another scene, you might call it home movie video editing. So you can just change the application to do whatever you want particularly. So basically, I'll walk you around the screen. You've got a preview screen over here, which is in actual fact this one. And then you've got a program one, so to air, if you like. So in that, under your scene, I've got all these different sources. So, and the sources in this little menu here are all hierarchical. So if I was to say test pattern and switch it on, and then say transition, it will put that test pattern to air. Now you might look down here. This microphone that's going on here is this little AirHug camera thingy that I've got. So not only do you get to be able to move the video back and forward, but you also get an audio mixer as well, which works really, really well. Like, it's excellent. If I then say, I'm going to switch now to this little camera here called the Rotanium. So we'll take this hierarchy out, and you should see the next thing. Oops, today is not what we wanted. Why is that not doing? Of course, never, because that's on. There we go. And of course, it hasn't picked up the camera. So what I'm going to do is I'm going to show you how we will either pick up the camera, or I'll just have to reboot the software, and that's fine. So we go, as a matter of fact, I'll remove it. I'll remove that camera. I'm now going to add a camera. We add a video capture device. Actually, this is very good. We'll call it Rotanium, because that's sort of the name of the camera. And we'll say it's a USB camera. And look at that. It came up beautifully. So that camera is facing backwards off my table, looking back at the hall here, right? So that's in my preview, but what's going to air is my test pattern over here, okay? So all I would do is hit transition, and that's now gone to air. Really cool, really smooth. But you don't know who's sending this. Well, what I really should do is actually superimpose my call sign as some, and it's just too white. Let me just see if we can get this to work. Bear with me. No, hang on a moment. I've got to move this because we added a new one. There we go. So I'm just going to transition, and you can see I've superimposed my call sign over the top of it. So you can put text over the top of something, and you can see my audio still going, even though I've muted it here. Your desktop audio off your PC can be picked up. All these fantastic things. So if I wanted to go back to the AREG camera, which is the one that, in actual fact, is looking at the spectrum analyzer, I just do a transition, and there we are. So it makes all your elements that you're pulling together just infinitely controllable. It's really, really cool. Here is a little video I'll show you that I took many, many years ago. So it will play video as a source. So we'll liven this one up, and we'll do a transition. And believe me, there is sound there if I turn that up. So that's a Channel 7 helicopter there, and you can see the quality is pretty good. So that's all pretty groovy. And then if I wanted to go back, say, to my test pattern, just bring that up and then just simply do a transition. And there's my test pattern. And then I could mute that helicopter audio, and I could mute my desktop audio. You can just do all these things. And this is only touching on the tip of the iceberg. You know, you can have your transitions, fade times, fade to black, you cut, you name it. It will do all these sorts of things. The other thing it will do is actually allow you to put photographs, still images into the system. So here's a little slideshow that I put together of the John Moyle Field Day. So hopefully, and I'll do a transition. And there it goes. So it's me in my car with all my gear. And that was my HF antenna, top-loaded 12-meter vertical, worked really well. And all the 6-meter, 270, 23, all that sort of stuff. And it just goes round and round and round. So again, you can do all that. And that can be a still image if that's what you, in actual fact, want it to be. So we'll just go back to the test pattern and do a transition. And there we are. Now, the other thing that this will do is it will, and I can't demonstrate it because I don't have any internet here that I can actually port forward on, which is a pity, but maybe if you want to put the camera back on me, because I think we're just about done as far as looking at things are concerned. What you can do is open up or port forward on your router to where this program is living on a PC with a particular IP address on your home local area network. As long as you know your public facing IP address and that port number, you'll tell, I'll say Grant wants to put something to air, but he wants me to transmit it from my place. He would just get his copy of OBS, put his camera in, do exactly what I've done, point his stream, which is then pointed at my public-facing IP address with the correct port number as a suffix. It will then instantly end up in my OBS. I'll see Grant as a source, and I will then transition and put him to air, complete with video and audio. So it's sort of like a repeater without the RF. It's the possibilities are really quite endless. I wish I could have demonstrated that, but I can't do that here tonight. Take my word for it. It's easy to set up, and it just kind of works. So that's the story on that lot. So look, I reckon that's a bit of a taster, if you like. Just to recap, pretty cheap, pretty simple, pretty hard in that you've got to be spectrally pure. Just don't lose sight of that one. I encourage, we need more transmitters or it's never going to take off here in Adelaide. If all things being equal, I will be going to transmit the VK5 BV video presentation of the WIA broadcast on Sunday morning. So I will put that up. I'll put this test pattern up at half an hour beforehand, and I'll be listening on 147.4. So if you've got a set-top box or you've got a TV and you want to have a crack at it, if you start seeing signal quality and signal strength but no picture, all it means is that you've just got to do a scan, and I would just about say it will work out of the box, and then you too can be a person that will be there on the callback, which will be great. So with that, I think I will stop now and take any questions that anybody might have.
Okay, first of all, do we have any questions here in the hall? Yes, Mark.
Steve, you mentioned a repeater earlier on, or the thoughts of it.
Yep.
Go ahead.
Okay, well, let's talk about a repeater then, and I'll just put what, and again, I'm not being negative, I'm just calling it as I see it. These are my own opinions. So just to give you some idea, my 30-watt transmission from home consumes 600 watts from the mains. Okay, so electricity cost, going to be phenomenal. I'm not quite sure in a great location, because I think it has to be a great location. If you're going to put it in a good location, people are going to miss out. So a great location in Adelaide, what tower provider, building owner and whatnot are going to let you put a 7 megahertz transmission? Yeah, difficult, I think.
Only if we could get back to Halloran Hill.
And that's a possibility. Who knows? Obviously somewhere to put it. And then, of course, the equipment itself, but that's not the end of the earth. That's probably something that's doable. But then you need to come up with the cost, and that's just one channel, right? So if you did it as simple as this, just one channel. Over in Melbourne, their group's pretty strong. So they've got a 2-channel encoder up at Glen Waverley, up at the monastery there. And so they have 2 inputs. So it allows you to, I think you can come in off the internet and you can come in on 23 centimetres, I believe. And you can have 2 independent, complete different things going on at once. And if you either tune to one or the other, or if you've got 2 set-top boxes, you can watch both together or whatever you like, you know. So look, anything's doable. It's the will, who wants to do it, where are you going to put it, who's going to pay for the electricity, and the site rental.
You've got it a bit correctly. Okay. That's better. David.
Thank you, David, VK5KC. Now, the signal that you're transmitting is continuous. It's a continuous.
Me.
So it's a continuous transmission.
If I turn my transmitter on.
Oh, yeah. The reason, and it might be slightly off track, if we're playing something over the internet,
yes,
SBS, ABC iView, if you watch your internet stream, it comes in a burst of data.
Buffers, absolutely.
Buffers.
Yeah.
So that's a feature of the TV.
Well, it's a feature of whatever you're using to watch it. So if you're just using a browser, that codec is actually
well, it's TV. So your signal is continuous, but the digital data is buffered somehow.
Not in this.
No.
This is pretty much real time.
TV. So okay, thanks.
Yep.
Yeah, I will say this. It's quite different what you see on a streaming service.
Yes.
The streaming service does buffer stuff. Tries to buffer after 40, 50 seconds before it'll actually play sometimes.
Yeah.
This is real time.
Real time.
Well, real time minus transcoding delays. So it's a bit different. Alex.
I was just wondering if there's any real advantage to using the SatLink modulator over, say, an SDR transmitter.
Don't know. Try it and find out. Look, they all work, right? You know, probably some better than others. I don't know. As I said, this has got a feature in it that I like, but we'll talk about that later.
The question I've got, I mean, when I was in London and I went to the BATC, they were playing around with different bandwidths, like as small as 200 or 300 kilohertz, which meant they were down to like 576 lines, but still not bad for a 300 kilohertz transmission. I'm assuming these boxes can't do that modulation. I think that's where the SDRs have actually been used.
Indeed. You go and buy a set-top box, you plug it into an antenna, you scan it, it works. And what you're saying, absolutely valid. You know, you get yourself an SDR, but that's a little more complexity, a little bit more knowledge required, and so on.
Yeah,
Courses for courses.
That's what they're running over Eutelsat when they run 7 television channels in the transponder. But they're doing 7 channels in 7 megs.
Yep.
And that's the only way they do it. It's 1 meg channels.
Indeed.
Okay, other questions from the floor? No. Do we have any questions? I'll just walk back over to the console. Anybody on Zoom would like to ask a question, please come off mute now.
Yes, Steve, Scotty 2JX here.
Hello, Scotty.
I have a really stupidly obvious question. The program feed out of OBS, do you just feed straight out of a HDMI output on your laptop to your modulator?
Yes. So what I do, because I'm paranoid about putting things, being very careful what you put to air, okay? And so what I do is I run a little tiny HDMI splitter, so 1 input, 2 output. One of them goes to a dedicated monitor, so I know that whatever is on that monitor is being transmitted, and the other output goes off to the modulator. So that's my setup. No, in answer to your question, you could come straight out of your HDMI on your PC, plug it straight to the modulator. If you weren't watching off air, you wouldn't know precisely what you were doing. But you should also always be watching off air.
Yeah, perfect. Makes sense. Thanks.
Yep, cool.
Any other questions from Zoom?
One from Bill, VK5DSP. So it's normally multiplexed. DVB-T is normally a multiplex signal. You're just sending 1 channel. So do you use the same bandwidth, and what's in the rest of the bits? Or
Right, I think I understand the question. So it then just comes to the payload that you're putting to air. So, and that is determined by the mod cod. So if you want to put 4 channels to air, you're probably going to have to look at running 64 QAM, and that will get you about 23 or 24 megabits per second. And you could quite conceivably put 4 really high definition channels to air. But that then makes your whole system far more fragile, and you need very good carrier to noise, signal to noise for want of a better word, at your receiver terminal. So your coverage shrinks down. Now, how do the commercials get away with that? Well, they run 200-300 kilowatts of power. That's how they do it.
I guess an interesting example of that is to contrast the big commercials are running 20 kilowatt transmitters, 10 dB gain antennas, 200K EIRP. Ace Television is running a single transport stream, 8K, QPSK, much like we are.
Yes.
And their signal sometimes goes further than the big boys.
Indeed.
And they're only running 2 kilowatts on channel 36. Channel 34, I think it is.
Enormous amount of power for QPSK.
Yeah, and this is the thing. So even in the broadcast world, they're doing that here in Adelaide. That's what channel 44 is running.
Indeed. So very flexible, but you can change it with the push of a button.
Okay, do we have any other questions on Zoom?
Well, I have one quick survey, if I may. So I need you to get people to put their hands up on Zoom. And look, I guess I'll ask the hall first of all here. How many people have seen a amateur digital television transmission here in Adelaide? Could you put up your hand? Okay. Now, can I get you to all put up your hands, please? Because you've all seen one. Why have you all seen one? Because my whole presentation this evening was transmitted over DATV. It went from this little modulator through the system into my little set-top box and over there to the projector and to Zoomland. So you've all seen one, and you can see how good the quality is. All right, anybody else?
Nobody else from here?
No, all very good. Well, thank you very much for having me. I hope you got something out of it. Please consider becoming a transmitter if you're here in Adelaide. If you're elsewhere, gauge the interest of the area that you're in. But we need more people on. It would be really, really good. And very happy to help you on your journey if you need test equipment or some advice or whatever it might be. But it's not hard.
All right. Thank you very, very much indeed, Steve. It's been fantastic. Round of applause, everybody. And Jared's got a little presentation to make. So thank you very much, Steve, for all your efforts for us, and very much appreciated.